we go. So we're going to now do this pressure volume Boyles law lab, but we're really after the limitations in this experiment. So let's see if we can plot a Boyles law graph using this syringe here. So the first thing I'm going to do with this vernier pressure probe is I'm going to unscrew the bottom. Okay, and if you notice, okay, the pressure, if I move this over, I'm going to click on the pressure and just make it big so we can see it. The pressure is about 100.07 kilopascals. Okay, so you can see that pressure right there. All right, and that's close to 101.3 is standard pressure. Now it's kind of stormy out, right? Or I don't know. Don't know if these are even calibrated. But the next thing I'm going to do is I'm going to move this syringe, okay, so that it reads 80 millimeters. To do that, this black little piece, okay, is just going to touch the 80 because it's kind of conical, right? So the black piece just touches the 80. So I've set my initial volume. I'm going to screw this back in. The air pressure equals the pressure out here because it's open. I'm going to screw this back in. Okay, cool beans. All right, now, student A, okay, all right, you're going to hit the collect button. Cool beans. Now, you're going to hit the keep button. Shakes the mouse around. Okay, so if you notice, the computer just measured a pressure, which is approximately 100.1, okay? And it doesn't know the volume. So I want to type in 80 and hit OK. Okay, just plotted a point for us. Okay, that's the point it wants to make. Now, what we're going to do is we're going to put a book on here. Okay, so student C, student formerly known as Christy, okay? We're going to put a book here. Now, I may need help balancing this. Okay, let it try to stay on there the best we can. Okay, that's cool. And now you notice the pressure went up. So now you're going to balance a book on there the best that you can. Okay, and they're going to now you're going to tell them, now we're going to try to read this line, okay, that it is here, and we're going to estimate. Okay, and student C is going to help me. My eyes stink right now. So it looks like to me I got like 60. I got like 60. Well, it would be what? 60 to 70, 65, 63?
Yeah.
Okay, so 63. So type in 63. Okay. And it made a second point. Now notice there's the first point, there's a second point. Okay. Student C is going to add me another book. By adding more mass or weight, weight is mass times acceleration due to gravity, we're going to have a greater pressure on here. Okay, hopefully it balances. Okay, you might have to hold it. Okay. Now I have to read it so that student C, I don't drop this on my head. Now it says like 50. I'll say 51. Okay. Whoa, it stays there. Okay. Okay. Now we're going to go with 3 books. We're getting crazy. And it's going to get challenging now. Oh boy, yeah. So 3 books. Hold on. We're going to reset this because it's leaning. Okay. So I'm just going to try to change this up a little bit because it's kind of falling down to me. Okay. So we got 2 books that we had, 1 book at a time. 2 books. And again, I may need help. 3 books. You can just put a hand to that. Okay. Now I got to read that. And I see 44. Good job there, student A. Okay. Hand me 4th book. These old AP bio books. They're good for something. They're good for forms. No, they're not. Okay. Oh, now we got 4 books, and now I got 30. I say 38. And then 38. Okay. Should I dare do a 5th book?
Oh, yeah.
Okay. Can I borrow one?
Yeah.
Let's go crazy. Hope I don't break my system, but 5th book. Oh. Okay, can you read that? You read the volume, and I'll keep it there.
33.
33. enter. Now we're done with that. Now we can give this book back. Give the top book back. Okay, whoa. And I'll take these 4 off. Whoa, okay. All right. We're good. Okay, did you guys get 4 books or 3 books? Okay, so I'm gonna help you with this. 4th book goes here. I'll hold it so you can read it.
38.
38. Grab a book. Student C, can you give student M a book?
Yeah.
Student M is formerly known as Maximus. Okay, now read that.
That is 34.
Okay, you're good. Okay, now we're gonna go the other way. Okay, this doesn't need the books anymore. Don't hit any. Don't get crazy there, student A. Just cancel out of there. Okay, now what we're gonna do is we're gonna reset the pressure at a starting position. So I'm gonna open this up. Let this go back to starting position, and I'm gonna push this back to 80. Say, well, why wouldn't it go back to 80? Well, because there's some issues, okay, with our KMT, or connected molecular theory, that it doesn't, okay? All right, so now I'm gonna screw it back in so that we should be back in the initial pressure that we started with. Now, we're gonna go the other way now. Instead of pushing down, we're gonna pull out, okay? So I'm gonna pull out, student C is gonna read the volume. So I'm gonna try to pull till I get to a certain volume, okay? We'll do 10 a piece, okay? All right, and we're gonna add the other way. So now I'm gonna make the space bigger, okay? So I'm gonna pull up, and is that 10 more? Am I good?
A little more.
A little more?
Yeah, like that.
Okay, so add, so what's the volume now? 80, it's 90, right?
90.
So type in 90, hit okay. Okay, now I wanna add 100. Where am I at 100?
More up.
Okay,
More up.
there yet?
Yeah.
Okay.
100.
Okay, okay. 110, now it's getting more challenging.
120.
Am I there yet?
No.
130.
Yeah, that's it.
Okay,
A little less.
110, okay. I go 120.
You said 120 and then 130?
Yeah, I actually pulled it.
Right there.
130 now.
Is that 120? Yep, enter. Okay.
we'll just-
Okay, now we go 130.
Yeah, right there.
Okay, 140.
Yeah, right there.
And I'll do that. Okay. That'll be enough. Okay.
We had one
All right.
twice, but that's the one that
Now
was
we're going to
the
hit
one.
stop. Hit the red button. Okay. We have some points all over the place here. Okay. Any case, what we're going to do is we're going to click on the, is there another point here? You guys get the same thing?
Ours is larger.
Yeah, I don't know why that happened for you guys. So let me give you this, okay? And we're gonna stop this. I'm gonna type 140 here. Type 140 and hit enter. Good. Okay. So that's gonna be stretch out. Okay. So let's make a best fit line now. Okay. So what I'm gonna do is I'm gonna go to analyze, and I'm gonna do curve fit. So you're gonna look at on top. You're gonna hit the analyze button. We're in Logger Pro for these people out there, and I'm gonna hit a curve fit. Okay, and I get this pop-up window, and I want to use the inverse. Sometimes that doesn't work as well, so I think I'm gonna use the inverse. And I'm just gonna see. I'm gonna say try fit. So I click A over X, which is the inverse. I scroll down to get the inverse. Because, you know, pressure volume is an inverse relationship. I'm going to say try fit. Okay, that looks decent. So I put A over X, the inverse, try fit, and I said okay. And there is my curve. I don't really need this box, but I'll just move it over. So I got that. So what you guys are going to do is say try fit.
It will not. I think we have,
Oh, you have to,
we have an extra one right here too.
just hit cancel for a second. Okay.
Delete one of the 130s.
How do you do that?
It shouldn't matter. Oh, you have 2 in there?
Yeah.
It shouldn't matter. It makes best fit. You hit stopped, right?
Yeah.
Okay.
We logged one of the 130s when it was at the wrong point. So
I guess you can delete that. You can delete that right in there and then try that again. Okay.
Maybe the higher.
Okay, now,
Info.
all I need now is to print this. And you can see that nice inverse relationship. These are becoming asymptotic. And there's that Boyles law representative curve. Okay, so any case, we're going to print. I'm going to print everything. I want to print the values too. And we can change those names.
Maybe just click
Student A and student C. You can type that in now. Don't give it away.
Oh, it's already
Student A and student C. Okay. Cool beans. And we want 2 copies. So we'll type in 2 there. And we'll print that in the printer. And then we're going to go back to receipts and we'll finish the lab. Okay, cool. You're going to print don't print the graph, print the entire thing. So make two copies, back to receipts.
Yeah, that's good.
All right, so back to our seats. In fact, someone print me a copy. Print me one more copy for me. You want the data points. You want the data points as well as the graph. You need the data points. What do you mean?
Like the landscape.
No, you can definitely do it that way. It's fine. It gives you more room, actually. Okay, you're going to need some. Let's go. You've got an extra copy for me. Cool. Oh. All right. So there it is in all of its glory. And let's just going to do so. So what we're going to do is first we're going to do is do a little exercise in trying to get, hey, how many books equals a, we're going to try to figure out something. Let me just put this up here, get rid of this work here. It'll scare away my AP Bio students who will leave this up. They will not sign up. They see all this work on. Okay, so let me put this up here in all of its glory. All right, and then we're going to do a couple of calculations. Okay, and really easy, nothing really too earth-shattering here. Okay, so there's my graph. You can't see because it's too bright. Okay, I'm like myself. Oh, too small. All right. I know you guys can't print, but I will, I'll put one of these graphs, I'll put the graph that we saw on the video up. Okay, and we'll talk it together. Okay, so how do we do this? Okay, very simple. Okay, now, and you're going to help me with this group. The first thing I'm going to do is I want to find atmospheres per book. I want to find a converting factor, kilopascals per book. I want to find that. Okay, I want that converting factor. So here's what we do. Let's go find the pressure at 0 books. Okay, and I can't see as well as you guys can. So I'm assuming that this is 80 degrees. This is 80 milliliters right here?
Yes.
Okay, so this is 80 milliliters. So we're going to use the curve. Okay, so at 80 milliliters, okay, what was the approximate pressure? It looks like it was about, it was 101. So at 80 milliliters, starting, we had 0 books. Okay, what was the pressure at that point? 101.25 kPa, kilopascals. Okay. Now we had, hey, as you added more books, the pressure, the volume got smaller, correct? So this would be the 2nd book, 3rd book, 4th book, 5th book. What's kind of cool in this graph, see how the volume changes are not linear, becoming exponentially smaller? That's showing you this asymptote here. We're getting smaller. The volumes are doing it. So what's the, you guys did 5 books, right? So this is book 0, book 1, 2, 3, 4, and 5. So the 5th book, what was your pressure for the 5th book?
212.19.
Okay, so 212 for the 5th book. You had 212 point what?
How do you know this? I'm reading the.
You can just read off the chart if you want. For the 5th book, it's 212 point what?
212.19.
0.9 kilopascals. Okay, so 5 books, their weight contributed to this exponential changing of the volume. But more importantly, what's the difference between the two? Between the fifth book and 0 books. So I'm just going to write this 212.90 minus 101.25. Let's find out the total pressure that was contributed by the 5 books. So I'm subtracting. That's what? 6, 1, 1, 1. So I got, for you guys, 111.65 kilopascals. So what do I know? So I've got so I've got 111.65 kilopascals per 5 books. Let's go find the kilopascal per 1 book. So what do I do there? Divide. So divide that 111.65. Find the difference between 0 books and 5 books. I have that. What is that value for you guys? 22.33 kilopascals. That's per book. On average. It's not going to be perfect because you know it's, okay, but in your data there. Okay. Given that, how many books does it take to add an atmospheric pressure? Given that value now, let's go find out how many books. So, how many books? I'm solving for books. Now, what's the atmospheric pressure? 101.3 kilopascals. So if I want to add an additional atmospheric pressure on somebody, how many books would I put on their lap or their arm? So I start with that pressure. I get rid of kilopascals. I want books. And what do I know? For every 1 book, for you guys, it was 22.33 kilopascals. What do you get there? How many books, using those books, contribute to an extra atmospheric pressure? 4 points. What's that?
4.5.
Okay, so 4.5 of those AP Bio books contributed to an extra atmospheric pressure. So 4.5 of those books would be the same pressure of you being under 33 feet of water. Okay? That 33 feet of water is extra. Okay, cool. Now we're almost done. Last little piece of this. So the first part was to find the kilopascals per book. The second one, objective, you don't have to write it, number 2, was to find how many books contribute to an atmospheric pressure. And the third, okay, and you can do it right here. The third is I want you to solve for the constant. What did we learn earlier? We learned that volume is equal to 1 over P times a constant. That constant represents temperature and moles staying constant. So when I solve for that, hey, it's P times V equals a constant, right, algebraically. If pressure goes up, adding books, the volume went down proportionally, or inversely, I should say. That's only if K stays constant. So I want you to find me the value of K. In your data table, I believe you have volume and pressure. Times them together. Just make a what? Another table and solve for K for all your units. Multiply pressure times volume and find your K right now. You have about 2 minutes. If you don't finish that, you can finish that next lab period. But here is where kinetic molecular theory comes in. If the gases behaved appropriately, ideal, using my assumptions, that K would be the same. I want to know where it deviates the most. Where it deviates the most is where there's an issue with our gas laws. That K should stay constant. It should be the same number. Where is it going to be the most different? When the pressure was higher, the pressure was less? Where is it the most similar? We're going to answer that question another day. So to finish this out mathematically, all you got to do is pressure times volume, and you're out of here today. You don't have to finish this right now, but for homework, could you just multiply those together? And then you're done really with the mathematics. I just need to finish kinetic molecular theory, and we'll get back to this lab. But the key to this lab is, will that K stay the same? Where does it deviate the most? Where does it change the most? And that gives you some insight of where those assumptions to be an ideal gas, okay, are limiting. Have a great day, guys.